Hey guys, welcome to this page of the notes, and again what we're doing here, right, is I'm telling you two images, two figures are congruent. You're trying to find the transformation or the series of transformations that'll map this image onto this image or vice versa, this image onto this image, using rigid transformations to show that these two guys are congruent. So let's go ahead and do another one. Starting down here with WXYZ, this guy right down here. I need to figure out a way to get him flipped up here. Well, hopefully you can see, right? This guy right here kind of matches that guy right there, but they're almost kind of like reflections of each other. So I need to figure out some way to flip that guy over, and at this point you guys have seen it enough times. You should be able to recognize these on your own. We're going to go ahead and give that little x-axis a little spinny spin, 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 right? And that's going to flip this guy up. So we're going to go x comma y, right? That's this guy starting at x comma y. All of these points have an ordered pair. I'm going to reflect them across the x-axis. How do you do that? Change the sign of the y. So x comma y. There we go. Awesome. That's going to move everybody. Well, let's do it. X is 2 units. 2 units. So go 2 units above. 2 units. 2 units. Z is down 1, 2, 3, 4. So go up 4. Y is also down 4. 1, 2, 3. All right there. Awesome. Draw that guy in there. Fantastic. There it is. So my reflection across the x-axis. Now, I'm almost there. I'm really, really close. See, look, right? These guys are kind of, right? The orientation is the same. They're just in a different position. Well, how do you change position? Easy, easy. Do a translation. How far do I need to slide each of these points over to get them to line up? Well, slide this one over, 2. Slide this one over, 2. Slide that one over, 2. Got to move them all 2 units to the right. That's going to be x plus 2. The y's. How do I get the y's to line up? Well, this guy's got to come down. That guy's got to come down, down. Everybody's got to come down 1. So that'll be y minus 1. If I did that, it would take this green guy, map it right on to that image I've got right there. This performs all of my transformations. This was a reflection. This one is a translation. What do these do? It takes this guy right here, I reflect it, flip it up, I translate it, boom, and I take this image, place it right on top of this image, right? I map it to this guy. Rigid, rigid means congruent. These guys have to be congruent. I can write a series of rigid transformations. Rigid transformations preserve shape, preserve size. That means the figures are congruent. At this point, I've said it so many times, I probably sound like a broken record, but it's really important. Rigid transformations mean the two images are congruent. All right, finally, here we go. It's kind of a pain to have to constantly find a series of rigid transformations. Hopefully what you've seen in the last couple of problems that we've done, you've kind of thought to yourself, man, there has got to be an easier way. There is. There is an easier way. Now, you will still need to be able to do a series of rigid transformations. You will need to be able to do that. I am going to test you on it. It is what it is, but there is an easier way. And here it is. Congruence of segments and angles. Here we go. 2 angles are congruent if and only if they have the same measure. 2 segments are congruent if and only if they have the same length. Guys, that should make perfect sense, right? Remember, congruence is same measure, same shape, same length, same shape. So all we need to do to show that two figures are congruent, all the angles have to be the same. All the lengths of the sides have to be the same. So find the congruent angles? Well, we'll just extend that guy all the way through there, right? All of those rays are pointed in the exact same direction. Let's go ahead and extend the rest of the rays and see what happens. This guy extends up through here in that direction. This guy extends off through here in that direction. This guy extends off through here in this direction. Can you see which two of those lines, yellow, red, and green, right? Which ones are parallel? Which ones form the same angle? It should be visually pretty apparent, right? Yellow and green are the congruent angles. So angle A and angle C are congruent. Angle A is congruent to angle C, right? Now there's a couple of ways that you can do this. You could have used a protractor. Could have used a protractor to just simply measure each of those angles. You would have found that those two angles have the same measure. Well, that one is different, right? That one is different. Anyway, the idea here is simply this. If the angles have the same measure, they must be congruent. What about lines? Well, we already said when it comes to lines, they just simply must have the same length. They have to have the same length. If only we had a way to find the length of a line segment. Oh yeah, the distance formula. You guys will remember the distance formula. x2 minus x1, square it, plus y2 minus y1, square it. Take the square root of that whole thing, and what this does is it gives you the length of a line segment. Well, look at this. Here we go. That guy right there is at 1, 2, 2, comma, 1, 2, 3, 4. Right there. And B is at 1, 2, 3, 4, comma, 1. So 4, 1. Great. This guy, where's he? 1, 2, 3, 4, 5. He's at 5, 3. So 5, 3. What about this guy? Where's he? 1, 2, 3, 4, 5, 6, 7, 8, 9. How about 9, 5? 9 and 5. And then the last one, this guy. Where's he? 5, 6, 7, 1. And this guy, where's he at? He's going to be at 9, 4. Now that I know the coordinates of the endpoints of each of those line segments, guys, it's plug and chug, right? x1, y1, x2, y2, or flip it, whatever, it doesn't matter. x2, y2, x1, y1, same, you'll get the same answer either way. Doesn't matter how you label them, as long as you keep the x1 and the y1 and the x2 and the y2 together, you're good. Once you've labeled them, x1, y1, x2, y2, plug them in. Plug them into the formula. Don't fat finger something on your calculator, right? These should go pretty easy. We've practiced the distance formula many times. So go ahead, try these, right? See what you get. Here's what I've found. Make sure you get the same thing I get. Line segment AB, when you use the distance formula, is going to have a length of the square root of 13, right? Use these 2 points, this one and this one. Label them x1, y1, x2, y2. Plug them in. Don't fat finger something on your calculator. Should come up with the square root of 13. Okay, let's keep going. What about EF? EF. Again, label the points, x1, y1, x2, y2. Plug them in. Don't fat finger something on your calculator. I get the square root of 20. Question, same length? Nope, not the same. Square root of 13 is not equal to the square root of 20, which means line segment AB and line segment EF are not congruent. But let's keep going. We have a third one. So line segment CD. Label x1, y1, x2, y2. Plug them in. Don't fat finger something on your calculator. Look at that, cuckoo, cuckoo. Square root of 13. Here's what I now see. The line segment AB is congruent to the line segment CD. These two guys are congruent. How do I know? Same measure. Right? Same measure. How do we show congruence? Put that little hash through there. Hash there. Hash there. Remember, those hashes tell me that those two line segments have the same measure. They are congruent. All right, guys, thanks so much for joining me for this set of notes. What we're going to do is we're going to take this idea of congruent angles having the same measure and congruent line segments having the same measure, and we'll apply that to yet another little deeper understanding of congruency in the next section. So, thank you so much for joining me for this one. I can't wait to see you next time. Bye.